We're going to start our lesson with a video. Let's hope that this works the way it's supposed to. He's going to explain what pi means in 3 minutes and 14 seconds.
Pi. What is pi? Well, pretty much all of us know that pi is approximately 3.14, but that doesn't really tell us much about pi. What is pi? How did it get its name? Who discovered it? And how did they approximate it? Well, that's a lot to explain. So I've challenged myself to cover all of these bases in 3 minutes and 14 seconds. So without further ado, I present to you the complete history and complete explanation of pi in 3 minutes and 14 seconds. Somewhat. Here we go. Pi, not the kind you eat, but the kind you plug into your calculator to solve equations involving circles, spheres, and various other shapes. Most commonly approximated as 3.14 or 22/7, pi is an irrational number that is usually represented by the Greek symbol pi. Yes, the symbol as well as the number is referred to as pi. An irrational number, in case you didn't know, is a number with decimal places that spiral on infinitely with no discernible pattern. For a more formal definition of pi, let's look to the most forbidden of research sources, Wikipedia. Pi is commonly defined as the ratio of a circle's circumference to its diameter. Okay, look at the circle here. Are you looking at it? Look at it. Are you looking at it now? Okay, good. The diameter of this circle, which is, you probably notice from one side of a circle to a point on the direct opposite side, is 23. And the circumference, which is the distance around the entire circle, is about 72.25. If you divide the circumference by the diameter, you're going to get 3.14. This applies to all circles. If you get a tape measure and measure the diameter and the circumference of the circle, the ratio of the diameter to the circumference will always be pi, or approximately 3.14. Let's talk a little bit about the history of pi. Well, let's start with the most basic of questions, which is why did they name this somewhat aberrant number after a baked dish, which is usually made of a pastry dough casing that covers or completely contains a filling of very sweet or savory ingredients? I will answer your question now. The symbol of pi is actually a letter in the Greek alphabet. In both English and Greek, this letter, and therefore the number pi represents, is pronounced simply as pi. Popularizing this notation of pi is a man from the past who published a book in 1736 in which he referred to the ratio of the circle's diameter to its circumference as the Greek letter pi. This man's name was Leonhard Euler. Yes, I know it looks like Euler, but it's pronounced as Euler. You might have heard of him. He didn't have a ton to do with the actual discovery of pi, but he's still a pretty cool guy. This leads me to my next point. Who discovered pi? There's still a lot of debate about this. Some believe it to have been first approximated by the Egyptians because the construction of their pyramids leaves evidence of the architect's possible knowledge of pi. Others say no, it was the Babylonians in the 19th century BC. Gosh! So let's get forward a bit in history where things get a little bit clearer. The first recorded algorithm for rigorously calculating the value of pi was created by a man named Archimedes. Archimedes? Archimedes? So Archimedes devised a method of calculating pi by using regular polygons that were circumscribed and inscribed within and around a circle. An inscribed shape is a shape that is drawn within another shape without flexing or changing its dimensions. A circumscribed shape is a shape that's drawn around another shape without bending or flexing its dimensions. Archimedes computed upper and lower bounds of pi by drawing a regular hexagon inside and outside of a circle, and successively doubling the number of sides until he reached a 96-sided regular polygon. Any more sides and the universe implodes. By calculating the perimeters of these polygons and then dividing that number by the diameter of the circle, he proved 223 divided by 71 is less than pi is less than 22/7. Or 3.1408 is less than pi is less than 3.1429. This was a method of solving for pi that is accurate up to 2 decimal places. Both the upper bound and lower bound numbers contain 3.14. Nailed it.
All Okay, so that was supposed to be obviously a pi day video, but I wanted to put that on there just as a reminder of what is pi. You can tell me either from what we did Friday or what we did just now, what is pi? How do we find pi? How do we find pi, not how they find pi? Nina?
We find pi by taking the diameter divided, no, the circumference divided by the diameter.
Good, the circumference divided by the diameter. So it is the ratio of the circumference to the diameter. Is it different for bigger circles than it is for smaller circles? No, it's the same for all circles. I don't know if you caught what he was explaining about how they figured out pi. Since the circle, we can find the area of shapes with sides easier than we can a circle. So what he did is he took shapes and inscribed them in the circle and outside of the circle. And if you were to get an infinite number of sides, you would actually get pi, which is infinite. But that's hard for us to even comprehend. Let's see, I lost my chart here. Here we go. Okay, so we're going to practice finding circumference of some circles, and then we'll dive into some more involved problems. Okay, so the circles are not drawn to scale. It asks us to find the circumference of each circle, but instead of telling us to use 3.14, it tells us to use 22/7. Do you remember seeing that? That was on one side in the inequality in the video where he was figuring out pi was in between these two numbers, and 22/7 was actually one of the numbers. This is the other common approximation that people use for pi, and you should be equally fluent working with decimals and fractions, so we're going to actually do this using 22/7. Now, if I'm going to find the circumference of this, remember when we do area, we are using an approximation for pi. We're not using the real pi. It's impossible to use the real pi because nobody knows what it is except God. Nobody knows what pi is. It's infinite. It goes on forever and ever and ever. So we can't know it. So any answers we give for area are always approximations unless we do this. Circumference equals pi times the diameter. The diameter of the circle is 21 centimeters. So we can say that the circumference is 21 times pi centimeters. This is an exact answer. So if it asks you, and it does in the homework, it asks you to give an exact answer, you want to have your answer in terms of pi. You want to leave the pi symbol in your answer. Now we're going to approximate by using 22/7 as an approximation for pi. So we're going to take circumference equals 21 times 22/7, and that's going to give us our approximate answer. In fact, we should actually use, I erased more than I wanted to, we should actually use a little curvy equals to show that it is approximately. Okay, now, when we're working with fractions, remember we can put our whole number over 1. We can simplify across this way. 7 goes into 21 3 times. So we have 3 times 22, which is 66 centimeters. So the exact answer is 21 pi. The approximate answer is 66. And you can see 66 is a little more than 3 times 21, which is what we would expect. Okay, the next two I want you to try on your own. I want you to find first the exact answer and then the approximate answer, and then we will compare. Okay, let's look at this together. So the middle circle. Liz, what would be the circumference in an exact form in terms of pi?
91 times pi.
Good. Just 91 pi feet. And then what does the circumference work out to be when we use 22/7 as an approximation? Go ahead, Liz.
286
Good, about 286 feet. Okay, next one. Question.
If it asks us for the exact, would we write the equation?
If it asks you for the exact, you write 91 pi.
You don't write the answer.
Right, you don't write the answer. A lot of times, they will ask you to write things in terms of pi. And that's what it means. In terms of pi means you leave pi in your answer. Okay, Gretchen, you're actually up next. First of all, what part of the circle is given to us here? The radius. So what would the diameter of this circle be? No? The radius is 35 halves. What do we need to do to the radius to get the diameter? Liz? Multiply by 2. So if we multiply 35 halves by 2 over 1, the 2's cross out, and we're left with just 35. That makes sense. If the diameter is 35 meters, the radius should be half of that, or 35 divided by 2. Okay? So the diameter is 35. If the diameter is 35, what's the circumference in exact terms, in terms of pi? Lacey?
Circumference equals 35 pi.
Good. 35 pi meters. Okay, then using 22/7 as an approximation, Cole, what do we get?
I'm off.
You okay? So we have 35 times pi as an exact answer. So we need to take 35 and put 22/7 in for pi. So we're going to multiply times 22/7. 109.9, good, or we can round that to 110 meters. Okay, questions? Okay, let's take a look at the next example. Part B says the radius of a paper plate is 11.7 centimeters. Find the circumference to the nearest tenth. For this one, if you didn't like using the fractional approximation of pi, you get to use the decimal here. So you get to use 3.14. I'm going to give you a second. I want you to try B, and then we'll talk about it. Okay, most of you look good for this. The radius is 11.7 centimeters. So Katie, what would the diameter be?
23.4.
Okay, and then the circumference is pi times the diameter. We're using 3.14 for pi times 23.4. What do we get? Lacey? 73.5, good. 73.5, let's see, it's centimeters. Okay, letter D. Wait a second. I did the wrong one. I just did C. We need to take, look what I can do. This will be cool. I'm going to take no, I'm not going to do it that way. Let's see if I can. No, I can't do this. Anyhow, I thought I could lasso this and move it over to the other part, but I can't. So I just did part C. Part B is what we just did. Okay, part C is the same question. Okay? The radius of a paper plate is 11.7 centimeters. We're finding the circumference to the nearest hundredth. So instead of using 3.14, we're going to use the pi button on your calculator. So your calculator has a little button that stands for pi. So I want you to repeat this problem. Instead of 3.14 times 23.4, use your pi button. And tell me what you get as an answer. Zane?
73.5.
We want to round to the nearest hundredth in this case. So when we use the pi button, we get more than just 73.5. Adam?
C and B are not the same.
C and B on the other page are the same. They're both 11.7 centimeters.
B is rounded to the nearest tenth.
Right, right. But they're the same. It's the same radius. We're using a different thing and we're rounding to something different. So what would this round to when we round to the nearest hundredth? Good, 73.51. So for C, oh, there I'm doing that again. For C, we get that the circumference is about equal to 73.51 centimeters, and that's using the pi button on your calculator. Usually that will make a difference, but it's on down the line. So when we round to the nearest tenth, a lot of times you don't see a difference. It's when we round further that you may see a difference.
Why does it see though?
Okay, part D, it says a circle has a radius of r centimeters. So we're going to write an equation in general terms. A radius of r centimeters and a circumference of c centimeters. Write a formula that expresses the value of c in terms of r and pi. So our current formula is circumference equals pi times the diameter, right? How does the diameter relate to the radius? Katie?
What if you just divide the diameter by this?
You would divide the diameter by 2. So if we divide the diameter by 2, that gives us the radius, right? So let's solve this equation for D. What do we need to do to solve it for D? We'll have to get rid of this divided by 2. How do we get rid of that?
Multiply r by
Good, multiply actually both sides by 2. It crosses out here and we get D equals 2r. Now if D equals 2r and I substitute this into the other equation, what do I now have?
c equals pi 2r.
Times 2r. Good. Now to rewrite that, because usually when I have a formula I put the numbers first,
Yeah.
I can write it as c equals 2 pi r.
I wrote
You will see the formula given that way sometimes. In fact, it may be that way on your PSSA formula sheet. This is another formula for finding circumference. It's the same formula. It just uses the radius instead of the diameter. Question?
r times 2.
That's fine, but you want to rewrite it with the 2 first, just because that's conventional. Okay, part E. The figure below is in the shape of a semicircle. A semicircle is just an arc that's half of a circle. So a semicircle, semi means half, it's a half circle. Find the perimeter of the shape. How would we go about finding the perimeter of that shape? Athena?
You would find the circumference if there was a whole circle,
Mm-hmm.
and then you would cut it in half the circle.
Good. So we would find the circumference and we would cut it in half. So we would divide by 2. And would that give us the perimeter?
It would give us the perimeter of that shape.
Well, it would give us the perimeter of this. Because we're not counting this. When we find the perimeter of the whole circle or the circumference of the circle, we're not finding this. Gabby? Yeah, then we need to add the 8. What part of the circle is this? What is this called?
Diameter.
The diameter. So when we want to find, and you don't need a formula for this because you can figure it out, but if we were to write a formula for finding the perimeter of this shape, it's the circumference divided by 2 plus the diameter. So take a second and find what that would be, and then we'll compare that in a second. So let's go over this. Let's see. TJ, what is the circumference of the whole circle? Did you find that?
I did.
Okay, well, do it again real quick. So we have pi times, what do you use for the diameter?
So I got 25.13.
25.13? Okay. Now you don't want to round this off when you go to the next step. You want to leave it as 25.13 and round at the end. So we only need half of the circumference. So what is half of that? Lacey? You got something different? Did you do 3.14 times 8?
Yeah,
Okay, let's see what we get. 3.14 times 8 gives us 25.12. So TJ, did you use the calculator's pi instead of 3.14? Okay, see where that makes a little bit of a difference? And it did tell you to use the 3.14, not the calculator pi. So in this case, we're gonna take 25.12 as our correct answer. Okay, now taking half of this gives us what? Zoe? Half of 25.12. 12.56. Okay, so the circumference is about 12.56, half of the circumference. Plus, we need to add on this part, which is 8 meters. And 12.56 plus 8 gives us 20.56 meters. Okay, your assignment is going to be, on this paper you have a problem set. I believe there are 10 problems. Some of them are trickier than others. No, there's only 7 problems, so it's not so bad. Okay, so I want you to try those. It's okay to discuss your answers with somebody else, but you need to make sure you're doing your work and showing your work as you go. We have only 3 minutes, so there's not really much time to get started on this. I did all my work on this paper and it fit, so it can be done, but if you want to spread out a little bit, you can use extra paper to do your work and just put your answers on here.